Hello everyone, welcome back, JavaMentor.net here. In today's video, let's learn how to monitor your application. So you're creating some features, you deploy your application on the server, but you need to make sure that you have some monitoring options, like to see what's really happening on the server. Are there any 500 errors, or how many requests per second are coming to your server, so you must check for some metrics. Or whenever you have some problem and you want to debug your application, it would be very useful to have some monitoring endpoints that you will invoke, and then those endpoints will help you to find the problem. Let's see which endpoints I'm talking about. First of all, we want to learn about Spring Actuator. That is a small Spring tool that is helping you to monitor your application. So in order to learn that, we first need to introduce that Spring Boot Actuator using Gradle. So you need to add a dependency. That is a step number one. Step number two is to choose where your monitor data will be saved. So if you want to save your monitor data on some particular location out of your normal Spring Boot application, then you need to set this manager.server.port and management.server.address, as you can see on line 15 and 16, to some different values. But you can choose that your monitoring data stays on the same server as your Spring application and can listen to the same port. In that case, you can omit those two lines, 15 and 16. And I will choose to omit those two lines because it's simpler. If you run your application, everything should be fine. We still didn't learn about Spring security, so you don't need to bother yourself with that. But in the few tutorials, we will cover Spring security, and after that, you will need this line. So you want to say all endpoints that starts with Actuator, just permit everyone to access those endpoints. Otherwise, those endpoints will be inaccessible for you. Okay, let's start our application and see what we can do with this Actuator. Okay, our application started, and if we try get to this URL, we hit send. Note that here, if you specified special port for management endpoint, so if you specify inside your application properties, if you set management.server.port to, let's say, 9001, then in that case, here in the Postman, when you want to invoke Actuator endpoint, you need 9001 port. If you didn't specify the port, like we didn't, then you need 8080. We will receive some links. And the only endpoint on Actuator that is enabled by default is this health check endpoint, and that is a useful endpoint. So if you want to check that one, it's get method on Actuator/health. If you send request, you will receive up response, which means that your application is up and running. If this status returns down, that means that your application is not up and running. So basically, health check, which is what this Actuator/health endpoint is doing, is just telling you, is your application up and running? Of course, you can customize this health check endpoint to do some checks, and you can do whatever you like there. But in most simple words, this health check is used just to check, is your application up and running. If you want to learn more about these health checks, then I suggest you to check this reflectoring.io website, health check with Spring Boot. And here you really have plenty of things like what should you check, how should you check, really explained in details. Also, this guy has great articles about hexagonal architecture. I even bought his book about that. It was not that expensive, so if you're interested in that, feel free to check out. But this article is really on the topic of health checks. Okay, is there any other endpoints that we can enable in our Spring Actuator? Like this health check is okay, but I'm just guessing that you still don't understand why do we need endpoint for that. Like if we try any endpoint and if we hit send, if our application is, let's say, down, and if we try anything like books, maybe 8080, and we try send, we will receive connection refuse or could not send request, and we can realize from this that our application is not up and running. For this purpose, I suggest you to go to that article and read in more depth why do we need health check. Okay, let's now turn on all endpoints that Actuator can offer. For that, we need to go to application.properties and we want to go management.endpoints.web exposure.include equals to star, which means include everything. If you don't want to include everything, but you want just to include, I don't know, info and metrics, so you can do something like this. In this fashion, we only included info and metrics, but we want to include everything just to see what endpoints and what metrics and what monitoring info are available through this Spring Actuator. Okay, I'm restarting my application and I want to go here. Okay, our application is up and running. Now if we hit send, we can see that here we have a plenty of new endpoints. Let's go from the top to bottom. This beans endpoint is very interesting. So actuator/beans, it will return you all Spring beans that are defined inside your Spring context, inside your application context. So for example, there is a bean with this name, and that bean has scope singleton. I think we didn't talk about scopes, but anyway, you can Google out what is the bean scope, and that bean is of type of this class, and that class is located here, and that bean has those three dependencies. And for every bean, you have information about that bean. After the beans, you have, I'll just show some of the links, not all. So in our application, we said, if you remember from the previous tutorials, we wanted this bean to be inside the Spring context only if this condition is satisfied. So only if REST client.enable is equals to true, conditional on property. And we can find out this, is this satisfied or not when application is started. So if we go here to actuator.conditions, we can Ctrl F, Spring config, and it will tell you positive matches. So conditions that are satisfied. Spring config REST client, this bean is created, so condition is satisfied. Condition was on property condition, and this property matched. And then it goes for every single condition in your application. Of course, for example, this Spring doc configuration, this configuration is coming from your class path. It's inside your dependency OpenAPI starter. Okay, we included this through the Gradle. If you're not sure where is this OpenAPI coming from, you can go to terminal and you can type Gradle we dependencies. And then you should be able to see where is this OpenAPI minus starter minus common coming from. So here is the dependency tree. If you do Ctrl F and you type OpenAPI minus enter, okay, starter dot common. So this is coming from OpenAPI starter minus web MVC minus UI, and that is coming from Spring Boot Starter Data JPA. That is the root dependency. And then this is the transitive dependency of this one. We included only this root dependency in our Gradle file, right? Okay, that was regarding dependencies and where is this Spring dock configuration coming from. And you have positive matches, and at the end you have negative matches. So which bins are not created because condition was not satisfied. And you can find which one is not created and what is the reason, what condition was not satisfied. Okay, let's get back to other endpoints to see what else is here. Two interesting endpoints are heap dump and thread dump. We didn't talk about those two things. Those two things are not specific to Spring or something like that, but basically heap dump is a snapshot of your heap memory, of your RAM memory. So if you, let's say that you see that your application is consuming way more heap slash RAM memory than you would expect, right? You want to see which objects are allocating the memory. So you want to do a snapshot of your memory and then see what is the object type which is allocating a lot of memory. How to do that snapshot? Well, that snapshot is called heap dump. The similar thing you can do if you have some doubts about threads. So maybe you see that there are too many threads spawned, or some threads are working very slow. You suspect that some threads are blocked because threads can be in different states, running, blocked, and so on and so on. If you want to debug what's happening with the threads, you need thread dump. And both of those things you can analyze in some tools that are meant for analyzing heap and thread. Okay, I will not call those endpoints, but you got the point. After that, there is a metrics endpoint, and this one is very interesting. Those are the names of the metrics. So, for example, if you wanna see this Hikari CP is Hikari connection pool. So, how many connections to the database are maximum in your connection pool? You can check that in this fashion. So your connection pool can have at most 10 connections. That is the max. Okay, if you want to check something else, information about your Java virtual machine. This is basically telling you which Java version you are using and which vendor you are using, because there are some OpenJDK vendors, Oracle, and so on and so on. How much memory your Java is using, right? So JVM memory, and it will tell you the amount of used memory is this number. This is in this mathematical notation. Don't be confused. Google about E notation if you're not sure what is this. Okay, metrics, and there are plenty of other useful metrics here inside this metrics endpoint. Let's get back. Yeah, I mean, you can check all of them just to see what are they doing. Let's go after the metrics. The last interesting endpoint is this mappings. So you can find here all mappings that are exposed from your application. So you can see in my application I exposed /alt/register, and that is exposed through this authentication controller register method, right? Which I have in my application. I just recorded those videos out of the order, so I already included Spring Security. But this is the controller that is exposing login and register. Mappings, you can see that this is register is exposed. And of course, there are plenty of info there, like method is post, this is the URL, those are the request params, and so on and so on. Admin controller, let's see if there isn't something interesting. Yeah, this one, it says it produced JSON. Basically some information about your endpoints. And that is the last important endpoint that I wanted to show you regarding this actuator. But what if we want to count how many times this method is called, or how many times this method returned an exception. Count how many times 500, count how many times 404 error. Or we want to set some alerts. For example, if this method throw more than 2 exceptions per minute, hey, please create some alert. By alert, I mean please send an email to this email, and that email is the email of some senior developer, right? For that purpose, we need some monitoring tool. There are plenty of monitoring tools available. I'll just mention one of them, Prometheus. Another thing is we need to know about micrometer. Micrometer is some facade over all of those monitoring tools. So you need to add this micrometer registry Prometheus, because we are including Prometheus. We want to see how many times our method returns 200, how many seconds we spent in that method, and so on and so on. We would be able to do that with Prometheus. That's why we are adding this dependency micrometer, and we want a Prometheus facade. Okay, thing number 2 is to go to Prometheus website. Here, first steps with Prometheus. It's explained how to start Prometheus, blah blah blah. You have a link here to download the latest version, prometheus.io/download. So for Windows, you can go with this one, right? If you're using Linux or Mac, you can either use Docker Compose, or you can use, for example, if you're on Linux, this one. Okay, when you download that, you will have something like this. So if you go to extract that and you go to that folder, you have one YAML file. You need to instruct Prometheus to monitor your application, and that is done in this part. So basically you will have this config pre-configured, but in the third part, in this script configs, there will be some default data. You want to override that data to match your job application. So job name is Spring Boot application, and then you want to specify where is the Prometheus data exposed from your application. So Prometheus data is exposed from a Actuator Prometheus endpoint. That is why metrics path is Actuator Prometheus. And your application is located on localhost 8080. That's why that is the target of your job. So you're instructing Prometheus, hey, please scrap Prometheus data from localhost 8080/Actuator/Prometheus. When you save that YAML file, then you can go to the console and you can say prometheus.exe, and you want to pass as this config file equals prometheus.yaml. So that file that you just edited, enter, and Prometheus started. And Prometheus is collecting information about your Java Spring Boot application. Let's check that. So we have this Actuator/Prometheus endpoint now in our Actuator, right? Let's check that out. So if we call this Actuator Prometheus endpoint, and if you try to search for 200, so we want to see how many requests returned 200 status code, you can find here this HTTP server request seconds count is how many requests returned status 200. Now it has a very poor naming because it includes word seconds, but not sure why is that. But essentially that is the how many times your books/ID endpoint returned 200. This sum is how many seconds you spend inside the books/ID method. So on those 16 requests, in sum, they spend around 1/10 of the second inside the method. Okay, we can just try to hit few more times our endpoint in our Spring Boot application just to see if this number will change, right? So let's just try to hit 4 times our endpoint, And now let's go back. Well, now this is 20, right? Because we had 16 requests in the past and plus 4 that we just triggered. There were in total 20 requests. And if we try a little bit more, we can see that also this total amount of seconds spent inside that particular HTTP method is increasing. And there are plenty of useful metrics here. Okay, the next thing is we have great metrics, awesome metrics, but those metrics are in some weird textual format. We want to see that those metrics in a great visual format. For that reason, we need Grafana. So you can type download Grafana in your browser, go to the first link, and you can download Grafana for Windows. Download the installer, then you can install Grafana like any other video game, just next. And when the installation is done, you should access localhost on this port 3000. Then you should log in, username and password are admin. And when you are logged in, you will get to this home page. You want to go here to connections. Now you have a visualization tool. Grafana is not collecting any metrics. It's just visualizing already existing metrics. And you need to say, where is that already existing metrics? And that already existing metrics is inside Prometheus in our case, right? So you want to connect Prometheus, and the URL of our Prometheus, we can click here, add new data source. URL for Prometheus is, if you didn't override the defaults, is localhost on port 9090. Okay, great. Leave everything default. You can say save and test, and you will get a message, probably successfully queried the Prometheus API. Okay, now that your Grafana is connected to Prometheus, you want to create a new dashboard in Grafana. So you can click here, add visualization. You can select data source because this one Grafana can have multiple sources. So you can visualize data about multiple applications. In our case, we only have one, so we will select this Prometheus. Awesome, and then you need to create some panel, right? So let's pick this one. We want to know how many times 200 status code was returned from this books/id endpoint. So you copy paste that key, because here, if you can see in Actuator Prometheus endpoint, everything is in key value format. This is key, this is value, this is key, everything on the left, and this is value. So you want to copy one key and paste that key here. Select. Okay, you can say run queries, and it will tell you at this time the value was 7, and then just a few seconds after that it went to 11. So if you try to call your application a few more times through the postman, let's say, then you need to wait a few seconds so those requests are tracked with your Grafana. And if you click run queries, you will see, well, now we have, instead of 11, we have 14 requests here. I told you you need to wait a little bit, because if you take a look at this Prometheus YAML, scrape interval is 15 seconds, which means that Prometheus is querying your Spring Boot application every 15 seconds. So you need 15 seconds to see your metrics data in Prometheus, and then Grafana, if you click here in query options, Grafana is querying every 20 seconds by default. Grafana is querying every 20 seconds to Prometheus. So basically, when you click on some requests, you need 20 seconds to see that change in your Grafana. If we just copy paste the ID here, run query, you will see what was the value of that key over time. But let's say we want to see how many requests we had per second. So we only see the total number of requests. At some point was 7, then after that it was 11, then it was 14. But what if we want to see how many requests per second we had? For that purpose, we need this rate function of Grafana. First of all, you want to switch from builder to code. Then you had this key, right? So you want to do something like this. You want to call a rate function, and as an argument, you want to pass your key, and then inside those array brackets, you want to put 1 minute. And then let me explain you what I just did. So what's happening here? Here you have an explanation what is the rate function of Grafana, and it basically goes like this. For 1 minute, take all requests. So let's say that in 1 minute you have 100 requests, and you want to approximate that 100 requests to be a per second metric. So if you have 1 minute, to approximate 100 requests to 1 second is 100 divided by 60, because there are 60 seconds in 1 minute. So if you had 100 requests in 1 minute, this will give you 100 divided by 60, and that is 1.66. Okay, in our case, we had somewhere around 6 requests per 1 minute. So 6 divided by 60 is somewhere around 0.1, and that is what this is. It is a bit confusing, and that is calculated for every minute. So if you want to present how many requests were per second, so if every time you're approximating by dividing by 60, then it has sense to put multiply by 60 here. Run query, and then we can see how many requests. 5.3 requests were at this point. Well, let's try to calculate without that multiplying. So 5.3 divided by 60, let's see how much is that. 5.3 divided by 60, that is the number that is showed here, right? 0.88. And that is a rate function. Here you can find many other functions that are present in Grafana. And this is basically how you create your dashboards. Okay, we just created there, and okay, we like this diagram. We can say save. You can give some name, blah, 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 just save. And then you have that dashboard that is present, right? You can take a look at the result. You can create multiple dashboards. You can do a lot of transformations. For example, if you go edit here, you can see here that you can transform data. You can combine multiple dashboards. Then you can create alerts, like if something go over some value, you should send mail to someone or any other alert, and so on and so on. And that's basically Grafana, visualization tool that is nicely showing your monitoring data. I just showed you one property, but you can do this for every single property. You can, for example, try to scrap usage of JVM memory over time, and then you will have some nice graph. And yeah, when you have this monitoring data, and if you see some weird spikes or something, you have time of that spike, and then you can try to find that exact time in your log and see is there anything that can help you inside your log. Of course, you can say I want to see last 5 minutes, last 2 days, from this time to this time, so you can choose some time range in the past, and there are really plenty of options. But it's just important to realize, why do we need Grafana? And the last important thing that I want to show you regarding this Spring Actuator is how to expose Git information. So sometimes your code is deployed, let's say, to QA environment, and someone is telling you, hey, something doesn't work, this bug is still present. And you're thinking, hey, how is that present? I just fixed the bug and pushed it to the branch that is deployed to the QA environment. But how to check that? Sometimes you're not sure. Maybe you deployed that changes to the QA, and then your colleague made some other changes, then maybe broke application again and deployed after you. What is the way to see what is the state that is deployed to QA? Which commit is the last one? From which branch it's deployed? Okay, for that information, you want to add this plugin inside your Gradle. So this is plugin that will expose Git information from your Actuator. And here you want to put those two properties. So you want to enable that Git info, and you want to show full info. And after this, if you try to call actuator/info, you can see current application, so this application is deployed from master branch, and that build is created at this time. This is the version, and this is the user that committed the last commit. And this is the last commit. This is the message. This is the hash of the last commit. So you can just check, okay, this is the last commit. And you can see, is your commit last? Did you deploy it from the right branch? And so on and so on. There are plenty of other info here, but basically those are the most important info. From which branch and which commit is the last on that branch. And that's everything that you really need to know regarding monitoring. See you in the next video.